Okay, good morning, everyone. Hold on, I need to admit to us. Okay, let us start. So a quick review for the framework of collection. And yesterday we already discussed the framework, so just get a quick review. And collection. So the collection is an interface and it provides a number of methods. And under it, we previously also saw some examples regarding list, and list is also an interface. And the queue is also interface. So this vertical line, so the DAG is also interface. So all of the concept we already know, is it? And then here is another vertical line. So between those two vertical line, we have some abstract classes. And so far we haven't used of any of those abstract classes. And the lowest level is the concrete classes within the framework. And we already learned stack, array list, linked list, and the priority queue we are going to discuss today. And the vector we are also going to do some quick study today. So that's the general frame hierarchy. And we also know that on top of this is that iterable interface. And that's also quite a useful concept. And iterable, and then we have that iterator interface. Okay, and will provide a convenient way to do the node, to do some one by one item visiting. Okay, so that's the general concept. And today we will then start off this part we already discussed. Yesterday, I remember with our example, we also saw the comparator interface, is it? And previously, we learned the comparable interface. Is it? And that comparable interface has a method called compare to. Compare to, is it? And compare to just has a single parameter, okay? Single parameter. And there is another, and the comparable interface, we also say it's basically gives you, we call it nature ordering. Okay, the other interface for comparison that we can use is called the comparator interface. Comparator interface. And here, the key point here is that sometimes you want to compare elements of different types, is it? And generally speaking, for comparable interfaces, the elements need to be some instance of comparable. Is it? So you, like what we show in our example, is it like that book example, it implements the comparable interface, is it? But sometimes like over here it says elements may not be instance, is it, of comparable, and or it says are not comparable. Is it? Then in this case, how do we use it? And also yesterday we also saw the collections class. Is it? The collections class provide a number of methods to deal with algorithms. Is it? And within that, sometimes some of the method, the parameter, it's a type of comparator. For example, that sort method is a sort method, and you have some collection, is it? Instance, collection instance. And then the second parameter you provide is comparator, so that you can define your comparison to let the sort follow the rule you define to do the comparison. So that's a concept. And for comparator interface, it's you need to here it says if you want to use it, you can implement this java.utility.comparator interface. Okay, and we also see yesterday in our example is what it provide. Basically, this comparator interface is also a functional interface. And I'm not sure if you still remember the concept of functional interface. In our previous chapters, we learned, and we also mentioned, is it? And a functional interface, and then you can, later on, we will see you can do lambda expression, okay? And for this comparator interface, what it has that compare method. The compare, and for the compare method, then it has two parameters. Okay, two parameters. So you're going to provide two objects to compare. Okay, to compare. So that's the difference between comparator and comparable interface. And also, generally speaking, for comparator interface, it's we don't call it nature ordering. We call it total ordering. Total ordering. Okay, so that's the idea. And we will see more examples, okay, to use the comparator interface. And the comparator, like I just said, it has this method called compare method, is it? And it has two objects that you can compare, okay? And later on in our example, you will also see comparator interface also has the other two methods that return comparator. It's called comparing method. And it also has another one called then comparing method. And we will say it's very convenient, okay, for us to do a lot of customizing. And especially we use all of this together with the collections classes algorithm, okay. So all of this, they are connected together. So that's the concept of comparator, and we will see more example. And the collections class, yesterday we discussed, and for this class, it has a number, so be careful, okay. Just this class has a number of static methods. Okay, static methods, so be careful, okay, it's not, so the main functionality for it is to provide algorithms, okay, for all of the other data structures to use, for ADT to use. Okay, so that's its main goal, okay, for this collections class. And then let's see, we already learned stack class. Here it says vector. There is another class, it's pretty similar, okay. And the difference between these two is vector class. Okay, both of them have a lot of, like over here it says vector, it's similar as array list, okay, similar as array list. And the major thing here is that the difference is vector contains synchronized method to access and modify vector, okay. So be careful, it says none of the new collection data structures introduce the synchronization. Okay, that's what its major feature is for synchronization. Okay, and because in our class we are not going to learn the parallel programming. Okay, like multi-threading, those parallel programming, but one of the major features has advantages that can expedite a lot of processing, as you can do some parallel processing. Then in that case, we need to think about the synchronization issue. Okay, so the basic idea is for parallel is you have a huge data set. Okay, huge data set. Is it? And so generally, based on what we learned, so far, what you can do is you needed to get it, is it, to your program, and then do one by one processing, is it? But if it's huge, then it will take a long time, is it? So a lot of cases, especially like for graphic, for like a computer graphic, then you can divide it into some small chunk, is it? And then each chunk you can use, especially like right now we have multi-core, is it? And then you can let like a graphic CPU, is it? And then they can distribute each chunk of the data for the CPU to do the simultaneously processing, and then you group all of the result together to do the final processing. So that's the basic idea of parallel processing. But regarding the parallel, then you need to synchronize. If we don't think, then it may cause a lot of issue. Okay, so you, in your future CS course, you will learn that concept. So anyway, so here, so in Java, because when you write program and you needed to, if we want to parallel processing, then how do we handle those synchronization issues? Is it with all of the collection data structure that we learned, is it? So some of them they support, some of these don't support. Then you need to pick the right one for your purpose. Okay, so that's the general idea. But we don't need to worry too much here in our class. And here it also provide a number of method for vector, is it? It has the add element, is it? And you can also retrieve where the element is it? Get the first element, you can also do insert element, get where the last element, you can also remove, is it? You can also set. So if you like it, you can also try with a vector, okay? And the stack we already learned, okay? It's LIFO. And the queue we also learned, okay? And the queue, remember here in collection, it's an interface, okay? And there is another kind of queue, and we will also see our example today. It's called priority queue, okay? Queue, generally speaking, is first in, first out, okay? But with priority queue, it's not just first in, first out, okay? What it does is it assigns each element with a certain priority, okay, with certain priority. And then whoever has the highest priority is going to be removed first, okay? So this is kind of like, you see, like in airplane, is it first class, comfort plus, such that, is it like this kind of, so they get the priority, is it a VIP, is it something like that? So with the priority, then even though you are not first in, first out, is it? You come late, but you have high priority, then the data structure will still arrange you as the first to be removed. Okay, so we will also see some of the examples regarding priority queue. And the queue we already learned. So for priority queue, we will see our example, but over here, if you take a look at the priority queue constructor, okay, so it has no parameter, and you can specify the capacity, is it? You can also specify with a certain data structure you want it to be started with a priority queue, is it? So those are all constructors. And the priority queue, so it has the problem of priority, is it? And because of priority, then you need to compare, is it? You need to compare. So the data structure, the elements that you want to add to this priority queue, they need to support compare. And regarding compare, we learned there are two and regarding the priority, the priority it involves compare. And the compare, previously we discussed there are two ways you can compare. That one is comparable interface. One is a comparator. The comparator. Okay, for comparable interface, we say it's a nature ordering. And for comparator, it's a total ordering. And the comparator is more flexible, is it? And so if like your item, like suppose our book class, is it, if it's implement a comparable interface, and if you want to build a book priority queue, then by default it's going to use the comparable interface of the class that you defined. Otherwise, then in this case, if your class, like suppose your book doesn't provide any comparable, it doesn't have, then how do you build a book priority queue? Then in that case, if you take a look here, you can use a constructor that you can define a comparator, okay? And then use a comparator interface, whatever it defined, the ordering to specify the priority. Okay, so that's regarding idea about priority. And then let's see. So let's move to our example. Okay, the example to have a better understanding. So we will start with the priority queue example. And for our priority queue example over here, the first part. Oh, let's first take a look at the book class. Okay, for this book class, for this priority queue, it's pretty similar as what we discussed yesterday. This book class also implements the comparable interface. Okay, so it does provide that, and we see. So that's our book class. And then over here, the first part, what we did is about a book array list. Okay, so this part, nothing new, okay? And then over here, we have a list too, is it? And we call the clone. And over here, it's try to show as it's not a deep copy, it's a shallow copy. Okay, so the clone method provided by the list interface is not a deep copy. Okay, so just be careful. And then over here, it's just show us the concept. And then you may ask, if the clone method doesn't provide the deep copy, but I do want to use a deep copy, is it? I want to create a deep clone of an existing array list. What should I do? Is it over here? It says you can basically. Here it shows we can use iterator to do it. So here it shows another usage for iterator. Okay, for iterator. So over here it shows we have this array list regarding book. It's empty at the beginning. And then what we are going to do is we use the iterator, as we specify where the starting place is. And then after that, what we did is, okay, we are going to do the loop. Is that to do the loop? So we are going to use the iterators clone. Is it? And for this iterators, so this iterator over here, what it returns is a book. Is it? It's a book instance. Is it? It's a book in, and the book instance you provide. You remember in our book class, is it? The clone method we defined. We defined a deep copy one. a deep copy. Is it? Then in this case, okay, then this book is going to be a deep copy book. Deep copy book. Is it? And deep copy book, then regarding this second list, you want to make a deep copy, is it? Then you explicitly call the add method, is it? Add the deep copy book to this second list. Then in this case, this list too is going to be a deep copy. Deep copy, okay? So here it just shows us we can get around it if the clone method itself from that data structure doesn't support deep copy, okay? And then next, let's see the priority queue, okay? So the next part is regarding priority queue. And regarding this priority queue, okay, let's see. We can have a couple of different ways to initiate our priority queue. The first one over here, what we defined, so we want to have a priority queue of book. Is it regarding book here? Okay, priority queue book. And what we did is we said, oh, new priority, nothing new here, okay. Okay, over here. And then what over here, where do we plug in? If you take a look, this is a lambda expression, is it? Lambda expression, okay. And if you take another closer look, you will find it has two parameters, is it? Two parameters, is it? And then what it compare? It compare the ID, is it? In this case, we should call that not ID because the ID is a private. You're not supposed to directly access. Is it? You can call the get ID method. Because book class has a get ID method, is it? So you can call that, is it? And why we can do this lambda expression, is it? What this represents, is it? And previously you remember one of the priority queue constructor, its parameter is a comparator. Is it as a type can be a comparator interface, is it? And the comparator interface, it has a method, we call it what? A compare method, is it? And that method has two parameters, is it? And then you can define your method, is it? So basically what's over here, this lambda, what it does is it creates a comparator. Is it an instance? Is it some class that implement this comparator interface? Is it? And then you create that class. Is it create an instance of that class? So that's what this lambda does. Is it? Okay, so that shows over here. And why we can do lambda expression here, that's because previously we said comparator interface is what? It's a functional interface. And it's not all of the interface you can do lambda, okay? So you can check what we learned before. It's because it's a functional interface. That's why you can over here write a lambda expression, okay? And what over here we did, so this is the one way you can create a priority queue, okay? You can plug in with some lambda expression, okay, to conduct whatever ordering that you want your priority queue to be based on, okay? So that's the priority queue. You can create a priority queue instance. And the second one, let's see, we can also do this. Over here to specify the capacity of this priority queue, okay? We want to have 3 items. And then you can see over here, it, let me just clear it. And then the second parameter, So this is the constructor. Is it the starting parenthesis and the ending parenthesis? Is it and the semicolon? Is it? And within the parameter, within this constructor, we have two parameters. The first parameter is a number. Is it? This is number of items. Is it? So number of items in your priority queue. Okay. The second parameter, did you see it explicitly called new? Is it? And the constructor of the comparator. Is it? And within it, over here, it has the curly brackets. Is it? So it's going to create an instance of the book comparator. Is it? And what over here, it does the overriding. Is it override what? That compare method. Is a compare method, it has two parameters, two book. Okay, and what over here is supposed to call that get ID for the comparison. Okay, because of encapsulation, is it? And what is this new? Is it? This is previously we also learned it's anonymous class. That's the concept. Then from anonymous, if you want to do more concise coding, you can write as the lambda expression. Okay, so here it just shows you can also use anonymous class to create a priority queue. Okay, with the comparator interface. Okay, so here it shows the second way. And then let's take a look at the remaining part. Okay, remaining part over here, we create some book instance, is it? And then let's see this book priority queue. Okay, and this time we call priority queue, is it? And if you take another look of its code over here, here it is specific, it doesn't have new. Okay, it also doesn't have the lambda expression, is it? It just provides the name comparator interface, is it? And then called dot, it says dot, and the comparing method. Okay, so this is a method called comparing. And in this regarding, what do you think this comparing method is? Previously, we said comparator interface. Comparator interface, is it? And it is what? It's a functional interface. And the functional interface follow what? Follow that SAM rule. Is it? SAM is single abstract method. Is it? So it only has one single abstract method called compare. Is it? So what is this comparing method mean? Basically, this is what? This is belongs to the static method. Is a static method. Okay, that's what it is it? And interface, it can have three types of method. Is it a default method? It can also be abstract method, default and static methods. Over here, it's referring it's a static method. This static method, it does some comparing. Okay, does some comparing, and then you can plug in what you want to compare. Is it based on what information you want to define for the compare? So over here it says, okay, I'm going to do based on ID for my comparison, and then you will see it has another dot. So over here it has a dot. Is it? And it has another dot. Then call another method called then comparing. So this is also a method. This is also a static method, is it? And then it plug in the criteria that you want to apply for comparison. Okay, comparison. And what are all of this? Okay, so then what does this part mean? Is it? So this comparing, so what the return type is? The return type. So the return type based on here, if we guessing, then it's a comparator. Okay, comparator. Not like the compare method. Okay, if you see this compared to the return type one, is an integer. Is it? For this comparing the method, the return type one, it's a comparator. Is it compare? That's why over here you can call dot again. Is it? Because basically this is a comparator. It's like you call comparator dot, then comparing again. Okay, so this kind is kind of, we call it a chained call. Chained call. Is it? Okay, so that's the idea of the comparing and comparing. Okay, and after you initialize this priority queue, then you can add whatever book. Is it? But here you define, when we add the book, what kind of ordering priority we are going to be based on. Over here define, oh, when you add the priority, first use ID as the priority. If both books have the same ID, then it's going to be based on name as a priority. Okay, so you can see it's quite flexible over here, that with a comparator interface. And then next it just shows, okay, we want to show what we have for our priority queue. And what the next part show is another array list. Over here is just add some book. Okay, so what this next part try to show us is regarding all of the collections. You remember collection, we say it's a class. Is it supports algorithm? Okay, algorithm. So algorithm means it has a bunch of methods. Okay, it can support you do something. The first one over here is called the sort method. Okay, and for this sort method, it didn't specify by what criteria it's going to sort. Is it? So it will use whatever the nature ordering. Okay, the book class supported. Is it? And the book class, the nature ordering supported is because the book class defines that comparable interface. Is it? So it's going to use whatever the comparable interface defined, then it's going to do the sorting. Okay, so that's the first case here. And then next, let's see. I can also call collection sort. Is it sort? And this time, if you take a look at the sort, what I did, I can also use a comparator. Is it to define my sorting criteria? So I call the comparator. I first going to use ID to sort. Then I'm going to use name based on sort. Is it? So yeah. So over here it just shows. Suppose if your book. So if the book class doesn't provide natural ordering. Natural ordering, is it? Then if you still want to sort the book, you can define your own. Is it? Your own. Is it? Call the comparator comparing and then comparing. Is it? So we can also do this kind of customized a rule for the comparison. Okay, so this is show the sort method from the collections class. Okay, and we can also do all sorts of search. Is it? And over here it says within the collection class it has a method called binary search. Okay, binary search. So we can also conduct a binary search. And previously, I remember I explained the binary search. The binary search in recursive part, we discussed the binary search. Is it for binary search to be able to conduct it? The precondition is what? Is the ADT must be sorted. Must be sorted. Is it? So in this case, this book may not already be sorted. Is it? Oh no, I'm sorry. So the book must be sorted. Is it over here? This book This book, is it provides that book class, because it provides the nature ordering, is it? A nature ordering, and then over here we sort it, is it? We sort it. Binary search, okay. And then over here we already sorted the book, is it? That array list we already sorted, and then within that sorted array list we want to find this specific book, is it? With our binary search, okay. So the binary search, then you don't need to reinvent. You can just directly call binary search, and the binary search, you remember, it's faster, is it? Because general search is order of n, it's a linear growth, okay, linear growth. And the binary search, it's order of log n, is it? So log n, then it's just grow like this. So that's why it's faster, okay, for binary search. So that's the idea over here. Okay, the binary search you can call. And over here next, what it's trying to show is how do we find some biggest item or smallest item within a collection, is it? And you can also do it. You provide a maximum and a minimum, is it? And then you can you can find it. And all of this over here, it didn't specify, is it, by what kind of criteria you're going to find. So this all based on the nature ordering that you defined for that class, okay? Otherwise, for maximum, if you check the library, you will find it also supports the comparator, okay? So you can define what criteria it is for your largest or the smallest definition, okay? So that's the concept here. And what the next part show us is about Q, okay? And the Q, you remember, because Q is an interface, so you cannot call new, is it? So that's why over here you call new linked list, okay? Linked list, that's a concrete class, you can do that. So over here, we create a queue, is it? And then we try to see what the queue is it? So that's nothing new here. And then what the next part shows is a priority queue. Again, is it? And this time, this priority queue, what is based on a string, okay, for our priority queue. And that has 4 items, okay. And over here, it shows us 2 approaches. You can initialize this priority queue. Over here, what we use is, we use a lambda expression, okay. So this is a lambda expression again, okay? And based on what? When you define the priority, so the priority is based on string length, is it? It's based on that. That's what you want, is it? Or if you want, you can also do, you can also use anonymous class, is it? So you can also use anonymous class concept, is it? Create an instance of comparator. And the comparator is an interface. You cannot directly call new, is it? But over here, the concept is some class, is it? That class doesn't have name. That class going to implement this comparator interface. That's the concept. And here, same thing for the compare method. What you define is you're going to use a length to define. And then you can add a number of strings, is it, to this priority queue. And then we can also check the output, okay. So this is a priority queue. And then over here, next it shows another way we can create priority queue. And for this time, this priority queue said, I'm going to create a priority queue. I'm going to do the reverse order, okay. So you can also use the reverse order from the collections and to initialize the priority queue, okay? And then you can go ahead. Then in this case, the priority is from least priority, is it, to the highest priority, because you want to reverse it, is it? So that's the idea here. And we will also be able to see the running result. And then let's see the last part of this program. The last part of this program, what it shows is, oh, it just shows some more method we can do. And over here, it's, so if you have an array, okay, if you have an array, and over here is, you can also call this function called as list, okay, as list. So it will convert this to a list, okay, to a list, and then you can go ahead to use it to create like a queue or other data structures. So over here, it just shows us multiple ways you can play around with your data structure. And what the next part shows is about the DAC concept. Is that DAC is you can add not just at the back, you can also add at the front. Is it? And you can do remove also at both front and back. So that's why we call it DAC. But DAC is an interface in that collection hierarchy, is it? So the concrete class that will achieve the goal, it's called array DAC. Okay, so if you want to have some DAC be created, then you can call the array DAC. Okay, and over here, so you can add that at the back, and you can also add at the front, that at first. And the same thing for remove, it also support remove first and remove last, okay. So that's this example shows us the general idea about priority queue. And the focus is also on the comparator interface. Okay, so that's quite a flexible idea. So that's the this part of the example. And the last example in this part, let's take a look. This is regarding the queue and the stack. We combine both of them together in one application. So over here, we have a queue created. So if you take a look, it's pretty straightforward. It's just you create a number of book instance and add to the queue, is it? And then for queue, we can call remove, is it? And we can also call a poll, okay? And over here, it also shows us the difference between remove and the poll, okay, and remove and poll. And the remove method, it's a through exception. Okay, so be careful over here. Whenever you want to remove first from a queue, okay, if you call remove, then it's throw exception, okay. And if for poll, it just return no. Okay, so that's a major difference between these two methods. Everything else is the same. Okay, element and the pick, it's similar. Okay, so element can throw exception if queue is empty. Okay, but for pick, what it does is just return null. So it purely, so it gives you options. Is it you can choose you want to throw exception or you want just to deal with null. Is it? Then you can choose. Okay, so just give you some options over here. And the contain method, so nothing new, and we can also do for each loop, nothing new here. And the stack, okay, and stack is a concrete class itself, is it? So over here, we can call the push, is it, to add off the new book, okay? And we can get output, and we can also search some item within a stack, is it? And we can also pop the top item. And we can also get a look of the top item, is it? And the stack also itself also support the for each, is it? And we know that this is for each because of the iterable, is it? So the for each method, you can also go ahead to use it. Okay, so that's the general idea about the collections. Okay, so we are done with the discussion of the collections, and so tomorrow and Thursday we are going to learn some ideas about secured programming in Java. Okay, so what we needed to pay attention, and And next week, we are going to do a quick review for the final exam, plus some other interesting topic that we can discuss. And I think today we finish off the material. And for today's class, do you have any questions? So any questions? If there is no question, then you can just send out your name to our chat. And I will keep track of the attendance. And then I will see you all tomorrow. So please just send your name. Did everyone send the name? If everyone sends the name, then I'm going to just end the meeting, okay? So see you tomorrow.
See you tomorrow.
Bye.